I said that computer technology is automating the process of inventing. But it's misleading to think that that means computers are taking over everything or that computers will make human inventors obsolete. Far be it from that. In fact, the NASA antenna is a particularly good example of ways in which the invention automation technology that I've described can be used as a tool by human inventors to augment their own skills. And as a result, human inventors can work as partners or collaborators with invention automation technology. So the NASA engineers I mentioned did produce a set of initial antenna designs automatically using their evolutionary algorithms. But that initial set did not lead to the actual antenna I showed you in the photo directly. Instead, the team of human engineers looked at the initial set and realized that there was a problem, that the signal strengths produced by those antennas varied in a way that was undesirable. And so they modified the instructions they gave the software and said, favor antennas that produce smooth, unvarying signal strengths the next time around. They ran the software again with that new set of instructions, and that led to the final antenna. So this is a perfect example of a way in which the computer automated a significant part of the process, but didn't do everything. The human team then learned from the output in a way that they may not have been able to do without the computer as a tool in the first place. Fed their own learning back into the computer, which produced improved results. And that loop can keep going on and on. The end result is each of these two partners, the human and computer, contribute something significant, but they produce a result that's better than what either one could have produced working alone. And it's a very common feature of the kind of technologies I describe in the book. And when I speak to people about this, particularly engineers, it often assuages their fear, is often the initial reaction to what I tell them about, that they're going to be put out of work by computers. Instead, if you play your cards right and you learn how to use the technology, you can actually use it to become more effective than if you worked entirely on your own. I'll give you another example, also from a local company named Afanova. They have developed software. It's called IDEA. It stands for Interactive Design in Evolutionary Algorithms. If you're looking for them on the web, they're AFFINNOVA. They've got lots of great examples on their website. Cadbury, who owns 7-Up, went to them to help design their next round of product packaging for 7-Up. And they wanted to make sure that the product packaging reflected what consumers liked. Now, they could have done this the old-fashioned way, which is to get focus groups together in a room like this and sat them down with product designs and have them take surveys and tests. Well, there's problems with that kind of approach. One, it's very time-consuming. It's very costly. The amount of input you can get from consumers is very limited as a result. Well, what Afanova's software did is generate thousands, eventually millions of potential package designs for 7-Up. They had the 7-Up word. They had different colors, different background shapes, all in many different combinations, and displayed these possibilities to consumers over the web. People could then put in what they liked over the web. I like this color here. I like the word 7-Up in the left-hand corner. I like it within a circle rather than within a square. Whatever you preferred, you could put in through the software. The software, like in the case of the NASA antenna, used all of this input from thousands of people to generate another round of product packaging designs, and on, eventually evaluating millions of potential designs. Came up with 6 that the software liked the best, and Cadbury eventually picked one of those 6 as the one to use in its 7-Up Plus product. So this is another perfect example of human-computer collaboration producing a result that's better than what either could have produced on its own. the human and computer collaborator don't do the same thing as each other. In fact, in the cases that are most successful of human-computer collaboration, the human does what he or she does best, and the computer does what it does best. Well, what do humans do best? Humans are good at setting the goals, defining the problem, as I said earlier, that they want to solve. And humans are also good at providing aesthetic judgments, in the case of 7-Up, indicating what colors look better than others. This has been used to design new perfumes. It's not something computers can do very well, tell you which kind of scent smells better than another. Humans are great at that. What humans are not very good at is precisely what computers excel at: generating large numbers of possibilities quickly, evaluating those possibilities based on rules or feedback given to it by humans, and then making modifications. When you put those two together, that's when the human-computer partnership can really achieve more than either could do on its own.